Hello everyone. This video will show how to minimize surface area using graphical method. Now let's go over this example that we have right here. The volume of an open-top rectangular box is 36,000 cubic centimeters. The length of the rectangular base of the box is twice the width. What height will make the surface area as small as possible? The first step that we need to do is to sketch and label the given problem. So I'm just going to go ahead and sketch that up here. It says in the problem that the length is twice the width. So I can go ahead and change this length to 2W since it says twice the width. And so we can go ahead and determine the quantity from the given value, and we're going to write its equation. So the quantity that we have right here is volume. So I'm going to go ahead and write the formula for volume down here. So volume for this rectangular box is length times width times height. So we go ahead and plug values in. So it says that the volume is 36,000. So I write that up here. So that's 36,000 is equal to our length now is 2W. And then we have a width and a height. So I multiply this. So that would be 36,000 equals 2W squared H. Our next step here is to rearrange this equation that we have right here such that a variable is by itself on one side. Since it says here what height, so I need to isolate height by itself. So I can do that by dividing 2W squared from both sides. So this is the formula for the height that works for this problem. Now let's move on to the next step. We're supposed to determine the quantity to be maximized or minimized. In this case, the quantity that we need to minimize, because we see the word small. So we need to minimize it. And we're going to write its equation. So this is what we're going to do. So the one that we minimize here is the surface area. So looking at this picture that we have right here, we can determine the surface area using this formula. Now we remember that if we say surface area, that represents all the area of all the walls around the box. So we're going to start with the area of the front plus the area of the back plus the area on the left side wall plus the area of the right side, plus the area of the bottom. So we go ahead and determine the formula for each of these. So we're going to start with the area of the front. So in the front, the area here would be 2W times height. And then the area of the back is the same thing. The length is 2W and the height. The area on the left side. So notice that this is height and this one right here is width. So the area on the left side wall is actually height times width. The area on the right is width times height as well. And the area at the bottom is 2W and W. So we go ahead and simplify this. So we see like terms here. So these are all like terms. So that would be 2 plus 2, 4, 1, and 1 is 6. So the equation would come out. So the next step that we need to do is to plug in the value of H, or the formula for H that we got on this side of the equation right here to the H right here. So this equation would come out. So what I did was I plugged in this 18,000 W squared, which is the H here to the H on the surface area. So we go ahead and simplify this so we can cancel out the W and 1W from here so that our equation would come out. So this is the equation that we're going to graph on Desmos. We're supposed to change the variables to X and Y and use Desmos to sketch the graph for this. So we let a SA, or surface area, equal to Y, and we will let W equal to X. So this equation would come out. So we're going to sketch this on Desmos, and we determine the minimum of the graph, or that is the lowest point of the graph. So looking at this graph, the minimum value is 35,400. So this 30 that we have right here is represented as x, and this actually represents the width. And on the other hand, this 5,400 is represented as y, because this is pretty much like xy. And so we know that our x is the width and our y is the surface area. So this is the surface area of this box, and this is the width of this box. So I'm going to label this box. This width will become 30. Since we see that the length is 2w, so we go ahead and plug in 30 to the w. So 2 times 30 is 60. So the length of this is 60. Since we say that the height here is 18,000 over w squared, so when we plug in this w squared here, which is 30, so 18,000 divided by 30 squared is 20. So I can go ahead and change this height to 20. So these are the dimension of the box. The length is 60, the width is 30, the height is 20. So in this problem, what height will make the surface area as small as possible? The answer is 20. So I'm going to go ahead and write all the values that we got. So that is how we minimize the surface area using a graph and without using calculus.